All right. Hello, everyone. This is the second lesson. This is lesson number 43. We're continuing with the unit of how to solve exponential and logs. Specifically, this lesson is on how to solve logs with the product and quotient property. These are two things that are on your formula sheet, but I printed them on the notes. As a reminder, you can print out the notes, copy along. You can get out a sheet of notebook paper and write the notes as we go, and pause and rewind as you need to make sure you understand. But whatever way, just make sure you have the notes in some form or fashion so that you can refer back to it as you practice. Here is, I said I would start sometimes with like a brain teaser or a quote or something like that. So I want you to think about this. You can pause the video if you do not want to hear the answer. What goes through a door but never goes in or out? You can pause it if you don't want to hear the answer. What goes through a door but never goes through a door but never goes in or out? The answer is a keyhole. A keyhole. All right, just something to think about. All right, we will learn math, build character, never give up, and ask why. Let's get started with learning. So, product property. That's what this will start with. How do I zoom out? Okay. So the product property, this is what it looks like in your formula sheet. Basically, what it is saying is if the sum, so you have addition of two logs, have the same base, then they can be written as a product of the two with that base. A lot of words. Basically, too far. If you have the same base and there's addition, you can use a product property, which means you can multiply these two and write it as one. For example, you have a plus sign here, log with the same base. You could rewrite this as log base 2. The base doesn't change, so you don't multiply the base. The base stays as what it is, but you'll multiply these numbers. So in this case, it would be log base 2 of 32. Okay? Now, why does that work? Let's say we want to find what log base 2 of 32 is. We make this x. You could rewrite that as an exponential. So it would be 2 to the power of x equals 32, right? So what would x equal in this case? X would equal 5. 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. 2 times 2 is 4. 4 times 2 is 8. 8 times 2, 16. 16 times 2, 32. So 5 would be what that is. The reason why that works is, let's say you did them individually instead of multiplying them, like this. Log base 2 of 4 is 2. Okay, log base 2 of 4 is 2 because 2 to the power of 2 is 4, right? Log base 2 of 8 is 3 because 2 to the power of 3 is 8. So if you did them separately, you would still get the same thing. You would get 2 plus 3, which equals 5. So the basic premise of the product property is if you have logs that are being added and they have the same base, you can rewrite that by multiplying the two. Okay? So let's try that in the context of a problem where you're solving. So let's say you wanted to solve this for x. And you see that there is the same base. You see that there's an addition sign. That tells us that we are going to be using the product property. So what we would do is we would have log base 7. And we will be multiplying this and this, right? Oh, that's a minus, sorry. Now, we still have this plus 2 equals 2 over here. I'm just going to leave that as equals 2. So what we did here, just to make sure we're clear, we had the same base. Let me erase this so that we can see it more clearly. So we had the same base. We have a plus sign. So the product property tells us we will multiply this and this. So we would need to distribute that there. So it would end up being 2x minus 10. I still have this log base 7. That is being applied to all of this, so I need parentheses equals 2. Now, we got rid of both of the logs. Now we just have one log, and now we can solve this. And from here, we need to think, would we use the property of equality, like we learned last class? Or last class, last video. Or would we rewrite this in exponential? Now, I want you to take a minute to think about what you think the next step would be. You can pause it if you want. All right, so what you would do is you would rewrite this in exponential because this doesn't have a log on it. If this said log base 7 of 2, then you would set this equal to that. But because it doesn't have a log, you would rewrite it exponential as 7 to the power of 2 equals 2x minus 10. And then we would solve it from there. So 7 to the power of 2 would be 49 equals 2x minus 10. And it's just solving for x. Add 10. 2x equals 59. Divide by 2. We get x equals 59 over 2. And if we want to check our answer, we could plug that back in for x and see if it is true or false. That is how you solve with the product property. We're going to do another example. You can rewind if you didn't get that. All right, so let's say we want to solve this for x. We need to look and see we have a plus sign. We have bases which are the same. We can use the product property. So it's log base 3, x plus 4. So I'm putting this and this multiplied equals 3. So that is multiplying because it's addition. Product property. Then when we multiply this, we need to use FOIL because it's two binomials. So that times that is x squared, or box method. That times that is minus 2x. That times that is plus 4x. This times this is minus 8. And we can combine these two, right, to give us 2x. And bring this down, x squared, this is plus 2x. Bring this down, that's minus 8. Now keep in mind, all this is still in parentheses. We still have this log with it. We still have this negative 3 over here. I'm sorry, this positive 3. So what we did was we FOILed this, which basically gave us this in here. Okay, then we want to solve log base 3 of this equals 3. And in order to solve that, we need to think, are we using the property of equality or rewriting it exponential? And we will be rewriting it exponential. So 3 to the power of 3 equals all of this. And then we will solve. Now take note, this is a quadratic because it has an x squared, so we know we have to factor. We first have to deal with this. 3 to the power of 3 is 27. Because 3 times 3 times 3 is 27. Because we have a quadratic, we need everything on one side. So we're going to move this 27 to the other side. It'll be 0 equals x squared plus 2x minus 35. Because we have a quadratic, we need to factor. At the top goes a times c, at the bottom goes b. A is 1, c is negative 35. Multiply that, you get negative 35. B at the bottom is 2. Put the 2 at the bottom. What two numbers multiply to give us negative 35 and add up to give us 2? It's going to be 7 and negative 5. 7 times negative 5 is negative 35. 7 plus negative 5 is 2. We always divide by the a. In this case, it will be the same. So this will factor to x plus 7 and x minus 5 equals 0. When we solve that, this one will give us x equals negative 7. This one will give us x equals 5. If you remember from last lesson, when you finish, you need to, is there a way to make this bigger? Yes. You need to go back. Don't worry, I'll erase it. Give me a second. Okay. So you need to go back. And you need to see which one of these is true and false, because one could be true, one could be false. And as a reminder, the way that you know which one is false is if when you plug it in, what is left in parentheses is negative. So I see this as negative, so that's probably going to be likely, right? Like, let's say I plug this -7 in here. Log base 3 of -7 minus 2. Automatically, I know that's going to give me a negative. So this is false. Can't have the log of a negative. So then we check 5. So let's try 5. Log base 3, 5 plus 4, plus log base 3, plug in 5 there, equals 3. So that'd be log base 3 of 9, plus log base 3 of 3 equals 3. We could use a product property, log base 3, because it's addition, multiply those, 27. Is that statement true? Yes, because 3 to the power 3 is 27. So x equals 5 is true, and -7 is false. That's the property, the product property. Let's talk about one more property, the quotient property. Again, this is on your formula sheet. This one is if you see a subtraction. If it's subtraction, you're using the quotient property, which is when it's minus, you are dividing the two logs, or what's in parentheses there. So let's say, for example, you have this, and you want to rewrite that using the quotient property. You see a minus, you see the same base, so you would just rewrite that as log, base stays the same, of 2, of 10 divided by 2, or in other words, log base 2 of 5. So you would just take these and you would divide them. So if you have this, it'll be log, the base is 10 here, remember, of 4x squared over 2x. And if we simplify that, it would be log 4 divided by 2 would be 2. X squared divided by x would just be x. So that's how you would simplify that. So that's the quotient property. When it is minus, you would divide the two. Okay? All right, so let's actually do a couple problems of solving them. So solving for x, where you would apply the property. So looking at this, we see we have log base 3 of x plus 1 minus log base 3 of 2 equals 2. And let's say we want to solve this for x. So what we want to do here is see, can we use the quotient property or the product property? Because it's minus, it's quotient property. So it's log base 3, at the top we put x plus 1 over 2 equals 2. I haven't dealt with this 2 yet. We'll just bring it down. Now, looking at this, we want to solve for x. So we see we can rewrite this in exponential. It would be 3 to the power 2 equals that. Then when we solve this, 3 squared is 9. Solving for x, we multiply by 2. That'll be subtract 1. That'll be x equals 17. And we would check that by plugging that back in for x and seeing if it is true or false. Easy shortcut. If it equals a negative in parentheses, it's false. If not, it probably is true. All right, one last problem. So let's say we want to solve this one for x. We see that the bases are the same. We see that it's minus. So we can use the quotient property. The base stays the same. This goes at the top. This goes at the bottom. Can we divide this? Be careful here. Can we divide these two? The answer is no, because these are grouped together and these are grouped together. So we cannot divide them. What we can do, however, is rewrite this in exponential. 4 to the power 1 equals all of that. Okay. 4 to the power 1, that's just 4. And then here we can see that you can't divide these. So if you can't divide, what can we do to get rid of the fraction? We can multiply by x plus 5 so it can cross out. And whatever we do on one side, we do on the other side. Then you can distribute this. And we are at a step now where we don't have fractions, but we can see that we have an exponent that is quadratic, which means we're going to have to factor, which means we need everything on one side. So we need to move this over. I'm going to move this over at the same time. So it'll be 0 equals x squared, 3x minus 4x, negative 1x, minus 20. And then we need to use the x method of factoring. I'll do this part quickly. Negative 20 goes at the top. Negative 1 goes at the bottom. Negative 5 and 4. Negative 5 times 4 is negative 20. Negative 5 times 4 is negative 1. Divide by our a of 1. That's going to stay the same. So we're going to get x minus 5 and x plus 4 equals 0. That's just factoring. This one would end up with x equals 5. This would end up with x equals negative 4 when you solve for x. And the last step, remember, when you're solving logs is to see if they are true or false. The negative one is the easiest to check because more often than not, like, actually, this one is going to be a positive. So we actually need to check them. This one, they might both be true. So let's actually try the negative first. This might be a case in which it will work. So we have log base 4. I'm plugging in negative 4 for x. Sorry, that's kind of ugly. It's hard to write. Minus log base 4 of negative 4 plus 5 equals 1, right? This is going to be log base 4. That's going to be 16. That's going to be negative 12, so that's 4. This is 1. Log base 4 is 1 because 4 to the power 1 is 4. Log base 4 of 1 is 0 because 4 to the power 0 is 1. So that will work, and that's because these are not negative, even though this is negative. So this is actually true. If you did the same thing, you plugged in 5, it would also be true. So negative 4 and 5 are the two solutions to this one. And that's how you solve log with product property and quotient property. All right, y'all can do the practice. You should be able to do this week's practice now. Let me know if you have any questions.